Right now, while you are watching this, something is happening that almost nobody on Earth knows about. A telescope in the mountains of Chile just spotted a small, fast-moving dot of light drifting through the darkness toward our sun. That dot is moving too fast to be from here. That dot is moving in a direction that should not exist. And NASA just confirmed it is real. This is the story of the cosmic visitor approaching our solar system. If stories like this are why you are here, subscribe now and turn on the bell, because the next few minutes are going to change how you see the sky above your head forever. For most of your life, you have been told that the solar system is a quiet, settled place. The planets go around the sun. The moons go around the planets. The asteroids stay in their belts. The comets come and go on long, predictable loops. Everything has its place. Everything has its path. Nothing comes from outside. Nothing drifts in from the dark. The solar system is our neighborhood, and the edges of it are far away, beyond Pluto, beyond the Kuiper Belt, beyond the Oort cloud, which is a giant shell of icy rocks sitting at the edge of the sun's gravity. Most people think the solar system ends there. Most people think that is where the story stops. But here's the part they are not telling you. That picture is wrong. Things come in from outside. They have always been coming in. We just did not have the tools to see them. And now we do. And what we are seeing is changing everything. To understand why this is such a big deal, you have to understand what it means for something to come from outside the solar system. And to understand that, you have to go back to the beginning. The sun is a star. It sits in a neighborhood of stars we call the Milky Way, which is a galaxy, which is a giant swirling spiral of hundreds of billions of stars, all rotating slowly around a black hole at the center. Between the stars, there is space, lots of space. Most of it is empty, but not all of it. Out there, between the stars, there are rocks. There are chunks of ice. There are pieces of dust left over from old stars that died billions of years ago. There are comets that got kicked out of their own systems by the gravity of giant planets. And sometimes, one of those pieces drifts close enough to our sun that Earth's gravity, or the sun's gravity, pulls it in. Most of them are small. Most of them are dark. Most of them are impossible to see. But sometimes, one of them is big enough, or bright enough, or close enough that we can spot it. And when we do, we get to see something that was made somewhere else, something older than our sun, something from another place entirely. The first time we ever did that was in 2017. A telescope in Hawaii spotted a strange, thin, cigar-shaped object moving through the solar system. It was moving too fast to be from here. It was moving on a path that would not loop back around. It was going to come in, past the sun, and leave forever. Scientists named it One-Eye Oumuamua. The one means it was the first. The I means interstellar. The name is Hawaiian for scout or messenger from far away. And it was strange. It was long and thin, the shape of something no comet or asteroid had ever been. It did not have a tail, even though it was moving fast enough that the sun should have been burning off dust and gas from its surface. Some people wondered if it was natural. Some people wondered if it was artificial. Some people wondered if it was a probe from another civilization. Scientists spent years arguing about it. Most of them now think it was a natural rock, just a weird one. A piece of something from another star system that drifted into ours and never came back. But it was the first time we had ever seen something like that. The first time we had ever seen a visitor from outside. The second time was in 2019. A comet named 2I Borisov showed up. It was different. It had a tail. It looked like a normal comet, but its path was all wrong. Its path was so stretched out, so hyperbolic, which is just a fancy word for an open curve that does not loop back, that there was no way it could have come from our solar system. It had to have come from somewhere else. Another star, another system, another place. Scientists pointed every telescope they had at it. Hubble watched it. The Very Large Telescope in Chile watched it. The James Webb Space Telescope, which had not even launched yet, was being prepared to watch it if it lasted long enough. Borisov gave us our first real look at what a comet from another star looks like. And it looked, in many ways, just like ours. Same kind of ice, same kind of dust, same kind of chemistry, which means the building blocks of comets, and maybe the building blocks of planets, and maybe the building blocks of life, are not unique to our sun. They are everywhere. They drift between the stars like seeds, like messengers, like quiet pieces of a much bigger story. But here's the twist that makes the new discovery different. In July of 2025, a telescope called ATLAS, which is a NASA-funded survey telescope in Chile, spotted a new dot of light moving through the sky. It was reported to the Minor Planet Center, which is the official place where new objects in the solar system get cataloged. And when astronomers ran the numbers on its path, they realized it was not like the others. It was not like anything we had ever seen. It was moving faster than One-Eye Oumuamua. It was moving faster than 2I Borisov. It was coming in at a speed of about 60 kilometers per second relative to the sun, which is so fast that nothing in the solar system could ever catch it. Nothing in our solar system could ever slow it down. It was just passing through. And its path, the curve of its orbit, was not a loop. It was not an ellipse. It was a hyperbolic curve, which is the signature of something that does not belong here. Something that came from somewhere else. Something that is going to leave as soon as it is done. NASA confirmed it. They named it 3I Atlas. The 3 means it is the third. The I means interstellar. And it is real. Here's the second twist. 3I Atlas is not just another visitor. It is the oldest one we have ever seen. Scientists estimate that it may be more than 7 billion years old. 7 billion. Our sun is about 4.5 billion years old. The universe itself is about 13.5 billion years old. So 3I Atlas is older than our sun, older than our planet, older than almost everything we know. It was formed around some other star, in some other part of the galaxy, long before our solar system even existed. It drifted through the dark for billions of years. It survived the death of stars. It survived the collisions of galaxies. It survived the slow, quiet violence of the cosmos. And then, by chance, by pure luck, it drifted into our neighborhood. It passed through the inner solar system in late 2025, swung around the sun on October 29th, and is now heading back out into the dark. And we got to see it. We got to point our telescopes at it. We got to study it. And what we are finding is changing how we think about the galaxy. Think about what that means. For most of your life, you have been told that the solar system is a closed place, a bubble, a neighborhood with walls, but it is not. The solar system is open. Things come in, things go out. The galaxy is full of rocks and ice and dust drifting between the stars, and sometimes one of them finds its way to us. 3I Atlas is one of those, and it is old. Older than the sun, older than the dinosaurs by billions of years, older than the oceans, older than the air, and it came here. It came here and we caught it, not by chasing it, not by sending a probe, by being in the right place at the right time with the right telescope and the right cameras. The universe sent us a visitor that has been traveling for 7 billion years, and we happen to be looking. If this kind of story is what you come here for, subscribe now because we are just getting started. The next few years of sky surveys are going to find dozens more of these visitors, and you do not want to miss a single one of these moments. Let me back up for a second and explain why this matters for you, sitting here on Earth. Watching this video right now, you might think an interstellar comet is just a rock, just ice and dust drifting through the dark. But it is not just a rock. It is a messenger. It is a piece of somewhere else. And when we study it, we are studying something that we cannot reach, cannot touch, cannot visit. We cannot send a probe to another star. The distances are too big. The trip would take thousands of years. But the rocks come to us. The rocks bring the chemistry of other systems to our telescopes. And by reading them, by looking at the light they give off, by measuring what they are made of, we can learn what other stars are made of. We can learn what other planets are made of. We can learn whether the building blocks of life, the amino acids, the sugars, the molecules that make us, are common out there or rare. 3I Atlas is teaching us that those building blocks are old. They have been drifting between stars for billions of years. They have been everywhere. And that means life might be more common than we thought, or at least the ingredients for life might be more common than we thought. And that is the real reason this story matters. It is not just about a comet. It is about the fact that the galaxy is connected. It is about the fact that nothing in the universe is alone. Everything is drifting. Everything is mixing. Everything is sharing pieces of itself with everything else. Our solar system was not born from nothing. It was born from a cloud of gas and dust that had been drifting for billions of years before the sun even lit up. And the stuff in that cloud, the stuff that became the Earth, the moon, the oceans, the air, you, came from somewhere else. It came from older stars that died. It came from other parts of the galaxy. We are not local. We are not unique. We are made of the same stuff that makes up every comet, every asteroid, every interstellar visitor that drifts through the dark. We are part of the same cosmic recycling program. And 3I Atlas is proof of that. A 7 billion year old piece of someone else's neighborhood, drifting through ours, reminding us that we are not the center of anything. We are just one small part of a much bigger, much older, much stranger story. But here is the third twist. 3I Atlas is not the last one. There are more coming. The Vera Rubin Observatory, which is a new telescope in Chile that just started scanning the sky, is expected to find an interstellar visitor every few months. Every few months. Think about that. We went from never seeing one to seeing one every few years to seeing one every few months. The sky is full of these things. They have always been there. We just did not have the eyes to see them. And now we do. And now we are going to start finding them by the dozen. Some of them will be small, some of them will be old, some of them will be strange, some of them might be carrying chemistry we have never seen before, and every one of them will teach us something new about the galaxy. The telescope that caught 3I Atlas first is called ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System. It was built to watch for asteroids that might hit Earth. That is its job. That is what it does every night. It scans the sky, takes pictures, compares them, and flags anything that moves. Most of the time, it finds rocks that belong to our solar system. Most of the time, it finds near-Earth asteroids that pass by safely. But on July 1st, 2025, it found something that did not belong to our solar system, something that had come from somewhere else. And it raised the alarm, and the rest of the world's telescopes turned to look, and what they saw changed everything. Here is what I want you to sit with for a moment. For your entire life, you have lived under a sky that felt safe, a sky with the sun and the moon and the planets, all going around in their patterns, all predictable, all stable. But that is not the whole sky. That is just the local sky. Out beyond the planets, out beyond the comets, out in the dark between the stars, there are millions, maybe billions of objects drifting through the galaxy. Some of them are rocks. Some of them are ice. Some of them are dust. And some of them, every once in a while, drift close enough to us that our sun's gravity catches them for a moment. They swing past the planets. They get a little warmer. They give off a little gas. They show us a little piece of where they came from. And then they leave. They go back out into the dark. They keep drifting. And they keep carrying their secrets with them. We get one look, one moment, one chance to point our telescopes and learn what we can. And then they are gone, forever. Out into the galaxy, out into the long, slow journey between the stars. That is what 3I Atlas is doing right now. It is leaving. It swung past the sun in October of 2025. It is heading back out into the dark. It will never come back. It will drift through the Milky Way for billions more years, maybe passing other stars, maybe passing other planets, maybe getting caught by another sun somewhere far away. And we will never see it again. But for one moment, for a few months, in 2025, it was here. It was in our neighborhood. It was close enough to see. And we looked, and we learned. And what we learned is that we are not alone. Not in the sense of aliens, not in the sense of other civilizations, but in the sense that the galaxy is alive. The galaxy is moving. The galaxy is full of stuff that drifts between the stars. And some of that stuff comes here. Some of that stuff finds its way to us. And we get to study it. We get to learn from it. We get to see what the rest of the galaxy is made of. The universe is full of these quiet moments, full of these brief encounters, full of these pieces of somewhere else passing through. Every time we find one, every time we look at one, every time we measure one, we get a little smarter. We get a little closer to understanding what we are. And that is worth paying attention to. That is worth watching. That is worth staying awake for. So what happens next? The short answer is more of these. The Vera Rubin Observatory is going to find dozens more. The Atlas Survey is going to keep watching. New telescopes are being built. New surveys are being designed. The next interstellar visitor might already be on its way in. The next one might be older. The next one might be stranger. The next one might be carrying chemistry we have never seen. And when it gets here, when we find it, when we point our telescopes at it, we are going to learn something new again. We are going to find out something we did not know before. And the rulebook is going to get rewritten. Again. And here's the thing that should really stop you in your tracks. Every star in the sky is doing this. Every star has planets. Every star has rocks and ice drifting around it. Some of those rocks get kicked out by gravity. Some of them drift between the stars. Some of them end up here, which means the galaxy is mixing. The galaxy is sharing. The galaxy is sending pieces of itself from one place to another, slowly, quietly, across billions of years. Our solar system is part of that mix. The Earth is part of that mix. You are part of that mix. The atoms in your body were forged in stars that died before the sun was born. And the rocks that pass through our neighborhood carry the same kinds of atoms. We are all made of the same stuff. We are all drifting through the same galaxy, and every once in a while, one of those pieces comes close enough to visit. And we get to see it, and we get to know we are not alone. Drop a comment below and tell me what you think this means. Do you think we will find life on one of these visitors someday? Do you think the galaxy is full of more of them than we ever imagined? And if this kind of story matters to you, share this video with someone who still thinks the solar system is empty. They need to see this. Thank you for watching. Thank you for being the kind of person who actually wants to know what is really going on out there. I will see you in the next one.